Alright, hello everyone. Today I'm going to be posting a few different videos for you. The first one, I'm going to do a quick review of levers, and I'm going to tie that in to pulleys, how they're similar, how they're different. Then I'm going to go use that to make a new video to talk about mechanical advantage and torque. And then finally I'm going to post a third video going over homework 1, question number 7. So if you've had any questions on the lifting the earth assignment, hopefully this video will clear it up when we review levers. And if not, let me know and I will try again. Alright, so we talked about levers the other day. So let's imagine that I wanted to lift the engine out of my car. So I have my engine. I went onto Google and I found out my engine weighs about 404 pounds. So the weight of my engine is 404 pounds. I don't necessarily want to use pounds, right? We're going to want to stick to newtons. So to convert from pounds to newtons, I Googled this as well, there's 4.45 newtons in 1 pound. So I'm going to take this 4.45 newtons in 1 pound. That makes my pound units go away. 404 times 4.45 gives me a force of 1,800 newtons. So that is the force of gravity pulling down on my engine. That is the force I need to overcome to lift this thing up. And for this exercise, I want to do it with a pulley. So I'm going to have to get my lever. I want to get my lever underneath the engine, put in some fulcrum, and I want to be able to just stand over here on my lever using my body weight, and I want to make my engine go up. And if I am 180 pounds, I'm going to use the same conversion factor, 4.45 newtons over 1 pound. Pounds go away, and I end up with 800 newtons. So if all things were equal, if I were on a on a lever like this, and I stood here, and the engine was over here, the engine would win. It has more force than I do, so there would be more force here that would create torque, and the lever would rotate. I want it to be the opposite, so I'm making my lever arm here longer. And I'm going to say this is going to be 1 meter because I get to place it wherever I want. And I want to figure out how long this section of my lever needs to be, my input distance. So my force in times my distance in equaling my force out times my distance out. And if I look at that, this is my torque in equaling my torque out, which if I look on the front page means nothing will be moving. Basically what I'm finding out is the minimum distance needed on my lever to just start getting the engine moving. So my input force is 800 newtons times the distance. It's going to equal 1,800 newtons times that distance. So the distance of my lever, 1,800 newtons, divided by my 800 newtons, would be 2.25 meters, or a little over 7 feet. So I would need a 7-foot lever that is also strong enough to lift the engine, because if it's just wood, the wood's just going to snap. And I also have the little issue of the engine is inside my car. So it's going to be kind of hard to get the lever in position. And how that helps with the lifting the world assignment. Once you find out the force of gravity on the Earth, either find the mass of the Earth in kilograms and multiply that by g, or find the weight of the Earth in pounds and convert it to newtons. Then you do the same thing for your weight. And obviously I'm not going to check. I'm not going to make you stand on a scale so you can pick a number. But again, find that force in, so over here it's force out, and get that in the newtons. Then you're going to pick an output distance. All right. Now, if you want to really get into things, you can find the radius of the Earth and know that you'd have to go at least that far to get under the center point of the Earth for when you're lifting. But just pick some number there for your input distance, and then I want you to, your output distance, and then I want you to find your input distance. This is what we're looking for in that question. What is our input distance? All right, so that is lifting an engine with a lever. Now, I want to lift that same engine, 1,800 newtons, but now I'm going to try to use a pulley. All right, there are a couple different types of pulley. There's 3 types of pulley. The first one is a fixed pulley. So I'm going to hang my wheel and axle off the ceiling, and I'm going to have my rope go up and over the pulley and attached to my engine, and I'm going to try to lift it. Well, how many ropes are actually lifting the pulley? Just this one. This section of rope will be lifting the pulley. This one just changes the direction. It's one rope here, which means I'm going to need to pull with 1,800 newtons. That's kind of a lot. So next, I'm going to try it again. So I have my 1,800 newtons here. But this time, I'm going to put the pulley on the engine. I'm going to attach one end of the pulley to the ceiling. I'm going to come down and under, and then I'm going to stand, say, up on some platform. And I'm going to work my triceps now, and I'm going to pull up. So now, instead of just one rope pulling the engine in the direction I want it to move, I have 2 ropes. 1, 2. Both of these ropes are helping me pull up, which means each rope is going to bear some of the mass. So the force I would need now is 900 newtons. And which is still kind of a lot. So now if we use something like if I use a compound pulley is a combination of both, I can rig up something like this. I'm going to draw it in this fashion just so it's easier for you all to see. I'm going to have 2 sets of pulleys, a fixed pulley, the one attached to the ceiling up here, and I'm going to have a movable pulley attached to the engine down here. Now, if I run my rope through this, check my notes here to make sure I start in the right spot. There we go. I'm going to attach it here. I'm going to go around the first pulley and the second, and the third, and the fourth, and the fifth, and the sixth. Now, I get to stand down here on ground level, I get to pull down. So I'm going to be pulling in this direction, down. I still have an 1800 Newton engine, but now I have 1, 2, 3, 4, 5, 6 ropes helping me pull up. So my 1800 newtons divided by 6 ropes pulling it up means that I only have to use 300 newtons of force now. So that is the equivalent of about 70 pounds. Which might still seem like a lot, and it is, but it's definitely a lot better than lifting all 400 pounds of the engine by yourself. So as I add more and more pulleys, the easier and easier it's going to be to lift this engine. Now, where's the trade-off? Okay, so the trade-off, get this message out of the way, comes in when we look at the, when we look at the force in times distance in, using that mechanical advantage thing again, equaling force out times the distance out. Okay, so using this setup, I know I'm going to put in 300 newtons of force times some distance, and I'm going to get out 1800 newtons of force. And let's say I wanted to lift that engine the 1 meter. So I want it to go 3 feet up in the air so it's out of the car. And then I can push the car back or figure out some way to move the engine from side to side. The distance I'm going to need to pull this chain, this rope, is going to be 1800 divided by 300. So I'm now going to have to pull, my distance in is going to be 6 meters. So to move the engine 1 meter, I'm going to have to pull this rope 6 meters. But I would still think pulling 70 pounds for 6 meters, 18 feet, is going to be a lot easier than lifting 600 pounds by myself 3 feet. So now if I take this information and I want to find out actual mechanical advantage, it equals the force. Make sure I write this right. Force out over force in. So the mechanical advantage here would be force out 1800 newtons over my force in, which would be the 300 newtons. So my mechanical advantage is 6. If I look at it in terms of distance, my mechanical advantage is my distance in divided by my distance out. So that's going to be my 6 meters divided by 1 meter. So I get a mechanical advantage again of 6. This number, my mechanical advantage number of 6, I guess I wrote these on the wrong side. My mechanical advantage number of 6 tells me how effective my machine is at helping me do the work. The higher the number, the better it's going to be. If I go back here and I look at my first one, my one fixed pulley, force out over force in equals my mechanical advantage. My mechanical advantage equals 1800 over 1800. So here I have a mechanical advantage of 1. There's no advantage here, aside from the fact that it changes the direction I'm pulling it, instead of just grabbing this engine and trying to lift it. So the higher the mechanical advantage number, the better. If I look at this one here, for mechanical advantage, equals